Test, test, test. Yeah. OK, that works. So, well, that's me. That's me and Jason. I'm Sebastian. I'm from Cologne, Germany, and I'm mostly known as ASCII-Disco throughout the internet. So Twitter, GitHub, basically everywhere you can reach me via my handle ASCII-Disco. So if you have any questions, aside from getting to the question corner later on, just tweet them to me. I've been working with web stuff, making websites, e-commerce stuff, and so on for about 14 or 15 years now. For the past 6 years or 6.5 years, I've been working on smart home solutions for this company here. Basically, this is owned by Deutsche Telekom, and we build white label products, white label smart home hubs for other companies. For example, if any one of you is familiar with KPN's Smart Life system, that runs on the foundation we built. But before we actually get to the all technical details and all that shiny hardware stuff over here, I want to tell you a bit about the history of Seattle. So I've been to Seattle on vacation a year ago, and I was fascinated with the early history of that city. So to me, it's not just the history of Seattle. To me, it's the history of failure. Here you see a picture of Seattle in the early 19th century. Mostly woodloggers, or people benefiting from the woodlogging business, were living there. So lots of woods, lots of trees, that's what you do. And you see the houses are basically built right on the coastline. So Seattle is not right at the ocean. They call it a sound. I think we in Europe would say it's a fjord. But the interesting thing is, they basically lined up the houses directly at the coastline. So, back in the early 19th century, what did people do? They did just simply put all the crap and the litter and all the waste into the water, which is great if the tide is low. So then everything is just gone. The problem is, though, where it's low tide, there is high tide. And basically what happened is that all the litter they've thrown into the sea on high tide went back into the city. And not only the litter, so they also had some, well, let's say rudimentary toilets, or crappers as they were called there back then, which basically had a pipe going out, which was just simply going directly into the sea. So on high tide, the water was pushing back to the pipe, and, well, let's say the wealthy people of Seattle had their toilet built up on a throne, if you know what I mean. But yeah, so what did the people of Seattle do? They thought, yeah, what do we have enough of? We have enough sawdust, so maybe with our totally crappish mud streets, maybe it will help if we put sawdust on top. Of course, it didn't help. Everything that was ending up was the streets were looking like chocolate pudding with some cereal munched into, but yeah, no chocolate pudding, more excrements and so on. But hey, so the situation got worse and worse and worse until there was a big fire. And, well, nearly all of the city burned down. 29 blocks completely burned down. And this is a picture of the business district. So let me introduce you to the home of Microsoft, Amazon, and was it Boeing, the business district of Seattle. But yeah, so of course, that was an opportunity. So the mayor of Seattle back then said, OK, now that we have the chance, we're going to rebuild the city, like proper houses, streets above the tide line. We're going to have a proper sewage system, And the people of Seattle, the citizens, they were happy. They were like, yeah, let's do this. How long will it take? And the mayor of Seattle said, well, 10 years. I think in 10 years we're done. Well, people were not so happy anymore because they couldn't afford to close down their businesses for 10 years until the city of Seattle had built up the streets and all that stuff. And yeah, this is a picture of Seattle downtown. And this was the ground floor and the streets of the buildings in the late 19th century, which are now all underground. Because the people started rebuilding their homes, but the city of Seattle just said, well, you know what? We don't care what you do. We're going to build up the streets. And what the city of Seattle did back then was, well, basically, they were saying the streets are ours, and they built it like they wanted it to do above the tide line. And so when you stepped out of your ground floor, like out of the entrance of your home, you could have ended up with a 9-meter-high wall right in front of you and a street on top. So to visit your neighbor from across the street, you had to climb up a ladder, like 9 meters, cross the street, and on the other side, climb down a ladder. I mean, eventually, later on, the people got, well, caught up, and what before was like the first or the second floor of the building is now the ground floor, and the all ground floors are now underground, and you can actually have a wonderful tour for them. The thing is, they're quite infested with rats, so that was a bit scary. Well, who likes rats anyway? And yeah, that was like a quick tour of the history of Seattle. But you might think, why the heck am I telling you this? Because I believe, and many others do as well, that we're in the smart home space right close to that fire, something that will burn everything to the ground. We have unsatisfied users. We have an ecosystem that is fragmented beyond everything, well, you probably know. Like if you think the JavaScript framework ecosystem is fragmented, just take a look at the smart home protocols. It's just crazy. But the thing is, so we as people who build solutions for smart homes, we kind of like need to fire up a business today. We need to make money. We can't just like develop in the garage or in the back room for 10 years without getting any money and then coming up with the proper solution. So that is our problem. And effectively, this is the problem of the users, because we end up with smart home systems that look like this. This was, until 2 years ago, the user interface of Europe's most popular smart home automation system, although it has only been sold in Germany, Austria, and Switzerland, the Homematic system. The devices, proper German engineering. The UI, proper German engineering. Okay, and this is one of Europe's most popular open source home automation systems, which is called FHEM, which stands for Friendly Home Entertainment, whatever. Any Booking.com people here? You would appreciate this because it's written in Perl. For those who don't know, I've recently heard that the Booking.com backend is written in Perl. Perl is usually the thing I see when my cat jumps onto a keyboard, and I think, hey, that's valid Perl syntax. But yeah, question. We are, as developers, designers, what do we think when we hear that term IoT, Internet of Things? I bet you think of this, like I do most of the time. I mean, we think of devices, we think of systems, we think of protocols, platforms, well, technology. But we often forget about this. the users. And I say that from an implementer's perspective. I've been working in this business for 6.5 years now. We are not thinking enough about the user. We're building systems that actually clash with the user. We build horrible user experiences of complex systems, and we basically take that complexity and, well, the user ends up with that complexity mapped 101. We target not the average user, we target the experienced tech person. That is true for the most smart home systems out there today. And this is why things look like I've just showed you. The thing is, the core of technology, why do we as humans invent new technology? Because we want to enable ourselves. We invent technology to get better somehow. We invent new technology to enable the average person to do things they weren't capable of doing before, or to make hard things easy, or to make easy things just blur into the background. This is why we invent technology. We invent technology to enable us as humans to do something easy. Wow. And this is why we invent, as said, this extremely fragmented ecosystem of hundreds of different smart home protocols. And they're basically, if you take a look at Kickstarter, and there's this next startup getting on with their smart whatever, they don't stick to existing protocols. I mean, sometimes they stick at least to existing technologies like Bluetooth or Wi-Fi, but, well, mostly they just code up their own protocol. So, quick protocol tour. WTP, what the protocol? What do smart home protocols usually look like? So usually they're so they transmit in the so-called ISM frequency band. That stands for industrial, scientific, and medical. In Europe, many of them transmit at 868 megahertz. That's true for Z-Wave, partly Zigbee, an Ocean, and many others. Thing is, though, the regulations for that ISM frequencies in the US and Canada say they must transmit at 915 megahertz. In Japan, it's 940-something, so something completely different. Thing is, if you buy a Z-Wave device in the US and bring it here, won't work because it doesn't transmit on the same frequency. Keep that in mind. There are also the well-known frequencies, 2.4 gigahertz and 5 gigahertz, which work for Wi-Fi and Bluetooth, and also for Zigbee, or Thread, which is actually just a variation of Zigbee. Those protocols, they organize themselves either in star or in mesh topologies. So star topologies, that would be an ocean, for example, has one advantage over the mesh because it's fast, so the latency is low. In a mesh network, the thing is, like with Zigbee, you have a wide range because a signal can hop from a device to another device to another device and finally end up there where the command should have been gone in the first place. That brings latency. But it also brings us, well, the capability of expanding our network, wide range. There are also different discovery mechanisms. You might be familiar just within the network space with UPnP or Bonjour. There are many others. Basically, all the people who invent their own protocol invent their own discovery mechanism. And the protocols like Zigbee and Z-Wave, especially in Ocean, they're mostly designed for one single purpose, and this is to save energy, because you have a lot of devices who run on battery. And for example, with smoke detectors, we have the EU regulation that the batteries of smoke detectors must last 10 years. So if you have a connected smoke detector, it can't be connected to Wi-Fi and always on. That doesn't work because the battery run out of power after a couple of months. So some protocols are specifically designed to save energy. OK, so enough theory, enough history lessons. Let's get our hands dirty with some of the IoT hardware. We're going to build a lamp or light bulb that we can turn on with a switch. Yeah, surprisingly, I know. Just to demo it, let me see. Oh, that was this one. So I'm hitting the buttons, and I can turn off either that light bulb over here or that LED on the Arduino over here. Basic stuff. The thing is, this light switch, it runs on the Ocean protocol, which is pretty cool for light switches because this thing doesn't have a battery at all. The power it needs to transmit the message is generated by the kinetic energy when I press on that, which is quite cool. Thing is, though, signals can't be encrypted because not enough power. But yeah. So that is just a very simple thing. We turn on a light by pressing a button on a light switch. Let's check out the code behind it. This is very reduced, so you would never run that in production because it's totally unsecure and no error catching at all or whatever. So what we do is we connect to a USB signal serial device which can transmit and receive the signals via Ocean. Just some USB stick I use here. And then we're just listening to the Telegram messages coming in from the light switch. And if that button with the label 70 or the label 50 is pressed, we just send a GET request to another server. The server for the light bulb, which is connected via Bluetooth in the end, looks a bit like this. Also reduced. So the truly important thing here is that we have a server that listens to, just GET requests, route on and off, and in the end connects that to the Bluetooth powered bulb we have here, just by sending some weird strings. I won't explain what weird strings are, because I don't want to spoil all the Bluetooth fun for Niels later. If you don't know, the last talk of the day is basically all about web Bluetooth, so you'll get everything you need to know from Niels' talk. But as I said, the important thing is that our initial diagram that we have, light switch turns on bulb, doesn't look so simple anymore after we know the technology behind it. Because what we essentially have here is 4 computers plus the devices. So first of all, we have the light switch. Then we have something like this USB stick here, which receives and transmits the signals. Then we have some server or cloud component, which receives that. On the other side, we have the same thing, because it needs to receive the signal, which then gets transmitted to the Bluetooth signal adapter, and finally turns on the bulb. So you can repeat that for most of the smart home devices out there. They have a local network with their own protocol, then they have a gateway, and that communicates with the internet somehow. The thing is, though, that's not smart at all. Like, that's a home. I can turn on a light by using a light switch. That's not smart at all. It's not even automated. It's just a manual interaction we have. What we've done is we basically reinvented a light switch in the most complicated way one can think of. We used 4 computers and 2 devices which also have some computing power. And all we can do is turn on a light using a light switch. And this is very complex. And the average user, when we try to explain the smart home ecosystem to them, they're scared of this complexity because it just works as it is for them. And so we need to manage well which features we as smart home vendors need to present to them. And we also need to understand how we're going to present the features to them. So as said, that what we had here is not smart at all. So how do we end up with a smart home sometime in the future? Probably through the use of artificial intelligence. Also, I don't like AI or artificial intelligence, the term. I like the one Microsoft coined, cognitive services. It's just more appealing to me. So I think with cognitive services or artificial intelligence, we will get to the smart part in a smart home term. One thing will be, or are already today, natural language interfaces. So you're probably, like, one possible simplification of this is a responsive UI that is driven by a chatbot. So I'll leave the house, please, well, turn off the lights then. Same system just applies to Amazon Alexa or Google Home. In the end, they just turn that voice into text and then work on it and get the key points, etc., key factors, etc. But I think this isn't enough. So I prepared another tiny demo, which is most probably going to fail. We'll see. So let's start it. What I'm trying to show here is a mixture of a voice recognition and a gesture recognition system, which just died right after it started. Let's give it another try. As I said, it's kind of, wow. Yeah? Let's see if it works. So what I have here is like a mask of the video feed of my webcam. And it should recognize the light. It's a bit bad light situation here for that, but it should recognize my finger pointing to either that lamp or to that Arduino, and then saying, OK, I'm pointing to the right or I'm pointing to the left, which somehow works. Nah, I'm pointing to the right. I'm pointing to the right. Wow. But what? Well, maybe that will make it crash again. But it was worth a try. No, to be honest, it's a bit flaky. Like the OpenCV C bindings are a bit unstable. OK, just give it one more try. And then I'll point to that lamp to the right. It's OK. And I say, turn off that lamp. Then it's trying to analyze what I've just said. But that was quite a huge sound file because I forgot to put the listen button one more time. So let's give it one more try. OK, I'm pointing to the left, which is OK. Let's point to the right, to that lamp, and say, turn on that lamp. Analyzing takes a while because it's all done locally, so there's no remote service involved. I don't have internet access at the moment, so everything you see here is running with Node in the background. Getting to it in a bit. And there's quite a lot going on, so it's still running. And the thing it just got was, to you, Donna Tonanen. Great. Come on, one more time. Turn on that light. And cross the fingers. I mean, to be honest, I was pretty sure that this was going to fail. OK. Let's keep it that way and proceed with the day of failed demos and go back to the presentation somehow. Oh God. Keynote. Here we go. OK, so that wasn't so successful after all. If you just want to try out Mozilla's Deep Speech, which horribly failed for me this time, I have a GitHub demo open at my account AskIDisco, where you basically can have a running demo of this code, which does the speech recognition that that just sucked. Same goes for the OpenCV direction pointing thing I've tried, which works quite well in, let's say, at home or in my office, because in front of a white wall in a completely silent room, it works. So there's a GitHub repo. You can just clone it, npm install the dependencies, and try that at home. But even if that had worked, it would have still missing something there, some human counterpart. So when we talk, like even when I said turn on that light, it wouldn't be the same as talking to a human. It is different. So for my next example that I already prepared a couple of months ago, I was seeking for something that separates us humans the most from computers, from the machines, which are emotions, or the capability of understanding emotion. I set myself the task, how can I make my computer understand emotions on a very basic level, and then act on them? The thing is, you might say this is completely rubbish and, well, fine for your demo case, but there are actual scientific applications. So studies show that people who suffer from depression could actually benefit from a certain light temperature applied to them. So if my home could understand that I'm, as a depressed person, that I'm slipping into some depressive period, my home could take counteractions before that actually happens. So what I did is I measured myself. I took a couple of key factors just tailored to me, like, is my weight going up or down? How much did I sleep? Am I at home in Cologne or at the office in Darmstadt or somewhere else? How much did I smoke before it was noon? Then I gathered the data for 30 days, which is not much. So 30 days of that data is basically nothing. I used my Jawbound tracker at night to measure my sleep, my Nokia scale, which is Wi-Fi connected, to measure my weight. I used U-tracking app for measuring my location, video happiness, getting to that in a moment. And I used a Wi-Fi cam with face recognitions on my balcony, where I usually have a cigarette. With face happiness, I basically wrote, also with OpenCV, a tool that every morning when I opened up my laptop, it did take a picture of me and mark all the landmarks on my face, and then determined, am I happy, am I sad, am I suffering from fear, etc. The thing is, if you try to look happy in front of a camera on purpose, it's still better than trying to look sad in front of a camera on purpose. So I gathered the data, and in the end, I wrote a little tool using TensorFlow. Oh, sorry, that video should start. OK. I wrote a tool using TensorFlow, where in the beginning it was a different library, but then I switched to TensorFlow.js after that was available, that basically got all my key factors, in the end predicted the emotion that I was having based on the data I did enter the past 30 days. So I think maybe not with exactly these examples, but with smarter computations like this, we will be able to actually enable our users with that smart home technology. We will not make them regret spending 500 euros on some smart home hub to, well, do this. OK, so let's leave the glorified light switch where it belongs. I've done a couple of other talks. This was kind of like a general overview about everything. I've done talks about protocol reverse engineering and also fun and art talks with some games using smart home technology. They're all included in the sources and links here in the slides I will tweet after. And there's just one more thing I'd like to tell you. Don't be stupid. Don't be like Seattle. In whatever part of web technology you're working, don't put up a 9-meter-high wall in front of your users, because that's not going to work well. Thank you.